Okay, so simplifying the square root of a whole number. So a lot of times you're going to get square root problems that aren't perfect squares. Now a perfect square is something, if we go back to geometry for just a second, if you think of a square has four sides that are all equal. So a perfect square would be something where the sides are the same and there's no leftover pieces, okay? When we have something like the square root of 32 that you're seeing to your left here, that is a square, but it has some leftover parts on it, okay? And so we'll look at that in just a second. But a perfect square is something like 4 and 4. Well, 4 times 4 is 16, right? But a perfect square could also be 3 times 3, which is equal to 9, or 2 times 2, which is equal to 4. And it can go the other direction, 5 times 5, equal to 25, right? And so you can have these are all called perfect squares because they create squares that have no remaining parts on them. Now, let's go to the square root of 32. What I'm going to have to do with the square root of 32 is I'm going to have to create a situation in which I have a perfect square inside of the square root, okay? So if I look at 32, what I'm going to do is I'm going to break 32 down, okay? I'm going to break it down into its prime components. So I have 2 and 16. Then I'm going to get 2 and 8. Then I'm going to get 2 and 4. And then I'm going to get 2 and 2. All right. So I can see here I've got all these 2's. And what I need to do is I need to figure something out here where I would have an even number of 2's because this is a square root, which I know means it's to the 1/2 power. Because remember again, the square root of x is really x to the 1/2 power. And so if it's x to the 1/2 power, I need something that's even so that I can divide it by 2, okay? So if I look at this, I've got 4 2's, which means 2 times 2 is 4, times 2 is 8, times 2 is 16. So I know that 32 is really 16 times 2, and I have the square root of all that. Now remember from our previous problem, if we have the square, excuse me, let me do that. If I have a times b to a power, that's a to the m times b to the m, right? Well, guess what I can do over here? 16 times 2 all to the 1/2. That's using this rule here, rule 1. I just use rule 1 right here by creating a 1/2 power, and I've combined it with rule 2 because I have an a term and a b term right here. So now what I'm going to do is I'm going to use 2 into this next step, and I'm going to distribute the 1/2 through to the exponents of each term. So I'm going to have now 16 to the 1/2 times 2 to the 1/2. 16 I know is 4 squared to the 1/2 times 2 to the 1/2. I know that if I have a base to an exponent, let me just redo that, hold on. If I have a base to an exponent to another exponent, I simply multiply the 2 exponents. Well, over here, I have an exponent and an exponent, so I'm just going to multiply these two. Well, 2 times 1/2, I know it's going to be 1. So I'm going to write that out, though, as 2 over 2 times 2 to the 1/2. Bring it over here, that's just 4 times the square root of 2, because remember, the 1/2 power is just a square root. So let's look at this in terms of a visual representation. Okay, so look at this in terms of geometry. Okay, let's talk about perfect squares first. A perfect square is when the sides of a square are the exact same length. So let's say I have the square root of 4. What this is saying is this 4 that sits underneath the sign is really the area of a square, okay? So if I were to draw out the area of a square, notice we have 1, 2, 3, 4, okay? So there's our area of 4. When we take the square root of something, what we are finding is the sides of that square. We can see here that there are 2 here and 2 lengths here. So the sides of this square are the exact same. Therefore, the square root of 4 is equal to 2, because what we're trying to find is just the side, the length of the side of a square. So length of the side of a square. So let's look at the square root of 32 now, okay? And this is going to get a little more intensive. But basically what we can see here is that we're going to have, I'm going to just say 4 times 8 is 32. That's how I'm going to run this one. So if I were to count all this up, we would have 32. Let's just make sure. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, go. So 8 times 4 is 32. What we're going to do is we are going to create some perfect squares within this area model. And so what I'm going to see here is I'm going to see I have a 4 here, and I have 1, 2, 3, 4 here. So I have a perfect square here, right? And I have a perfect square here. Now the thing is, when you do this, you have to have an equal amount of perfect squares. Meaning you can't just have one, okay? So in this case, I have 2 perfect squares. So what I'm going to do is I'm going to draw out the 2 perfect squares over here. So there's one, there's the perfect square, and I have to multiply it by basically 2, right? So if I were to break this apart, you would see that this, okay, so there's one perfect square, and there's the other perfect square that's sitting inside there, okay? But that's not the purpose of this. What we want to just look at is the fact that, is the fact that we have the perfect square times 2. So because of this, we've got the group 16 times 2, okay? What we can see here is that this is a side of 4 and a side of 4. So 4 times 4 is 16, and this is side 2 and side 1. Now, the square root, remember, when I'm taking the square root of something, it's about what's the length of the sides. And if I have a perfect square, the length of the sides are going to be equal. So I know over here that I just have 4. Well, I can't take the square root of this other side, of this part here, because this is 2 and that's 1. So therefore, I'm just left with the square root of 2. Okay? So this is just kind of a visual approach to how that might work. If I were to take the square root of 32 and just look at it in terms of its algebraic approach, sorry about that, what we would have is we would say, okay, that's 4 times 8. You know what, I don't like 4 times 8. What I'm actually going to do is I'm going to do 16 times 2, because that's what I did over here, right? I had 16, group of 16, 2 times, so 16 times 2. And I'm going to take the square root of that, and the square root of that, and the square root of 16. I know that's 4 squared square root times the square root of 2, and 4 squared square rooted is just 4 times the square root of 2. Okay? And so that, hopefully you can kind of see an idea here as to a way to work with these square roots if you don't want to do it the algebraic way and kind of want to just look at it in terms of the geometric approach.